Hi everyone, welcome back to another ThinkSphere physics video, and I'm Gary. Today, we will explore one of the most common types of kinematic physics questions, projectile motion. Projectile motion is a type of motion where an object is undergoing a curved motion, usually curving in a parabolic shape, like something like this. There are a few different types of projectile motion, and we will cover all of them in a few videos. The key feature to distinguish each type of projectile motion is the firing method of the object or the projectile. The three types of projectile motion are firing horizontally, so if an object is firing horizontally and may go something, the trajectory will look like something like this. And firing with an angle from ground, so if this is ground and we have an object, we fire it with an angle and the trajectory will look something like this. And the final type is firing with an angle from a certain altitude. So we have some altitude right here and we still fire it with an angle, so it will look like something similar to this. Okay, so to understand how we should approach projectile motion, we should look at this picture right here. When doing projectile motion questions, always remember two things. On the vertical dimension, the object is undergoing an uniform accelerated motion. And on the horizontal dimension, the object is undergoing a uniform motion. What does this mean? This means, if we look at this image right here, these are two balls, one with color red and one with color yellow. They were fired at precisely the same time. And the red one dropped directly, and the yellow line has a horizontal initial velocity, so it goes like with a slight trajectory. A slight curve. But we can see that the increment in two balls, they align precisely at the same time. So when they are falling down, the acceleration they experience has the same magnitude. And we will see that since this object has no external forces, so there's only one force acting on both balls at that particular time, which is gravity. And the acceleration due to gravity is g equal to 9.81 meters per second squared. So this g would be the shared acceleration experienced by both balls. And if we look at this yellow ball right here, we can see that despite the fact that it has a horizontal initial velocity, that does not affect the vertical acceleration experienced through its motion. So actually, in fact, on the horizontal dimension, on the x-axis for this yellow ball, the velocity kept constant. And we will look at how that affects our problem solving in the next example questions. So, in this video, we will focus on firing horizontally with an initial velocity, this scenario. Let's look at this example question. If a baseball is thrown horizontally off of a rooftop with an initial velocity of 12 meters per second, what would be the range of a projectile if the building is 50 meters tall? So before solving this question, before we even delve into like what variables do we have, what data do we have, what numbers do we have, we need to understand what this vocabulary range means. So this word range means how long or what is the distance this projectile travels in the horizontal dimension. So if we draw a simple diagram, here's a baseball from a rooftop. It fires horizontally. It will go something like this if we think about it from a realistic length. And this would be the distance that the baseball traveled on the horizontal dimension, on the x-axis, and this would be the range of the baseball. So this is what we're looking for, and now we will start this question by listing what we have. So we have a initial velocity of 12 meters per second. We have a 50 meters, which is the building's height. And what is this building's height precisely in terms of the motion that the baseball is undergoing? This would be the vertical displacement, or the displacement on the y-axis, right? It is 50 meters down. And we have a constant acceleration due to gravity all the time through the motion, which is 9.81 meters per second. And be careful about the direction, also down. So since we have a few directions here, we better define the direction that we're going to use. So we are going to define that up is positive and down is negative. So we have these three data, or three numbers we have in this question. And we're looking for the range. So since we talked about resolving a component in the previous video, we will look at how can we resolve this initial velocity. So we have an initial velocity of 12 meters per second off of a rooftop. And we can see that it seems like we only have one, it's a horizontal vector, so it only has one component. So there's no need for us to resolve it further. So this would be the only component it has, which is, we'll call it the vector on the x axis, horizontal component. And as we talked about before in this video, that for any object that is undergoing a projectile motion, the horizontal component of the initial velocity is always constant. So this is constant. It's just this 12 meters per second is always 12 meters per second. So we want to look at the range, which is essentially the displacement on the x-axis. So how will we calculate that? This will simply be distance equal to velocity times time. This time is just time, but this velocity, what is this velocity? Is this horizontal velocity, vertical velocity, initial velocity? What kind of velocity are we using? Since we have a underscore of x here, we'll just say it's the horizontal velocity because we're looking for the horizontal displacement. So this would be the formula that we're using. Do we know the horizontal velocity? Yes, it's 12 meters per second. Do we know the time? Maybe not. So we are going to look for this time first. So how should we do that? We still have these two informations untouched right here. So we're going to see what can we make up use of those two things. So we have this. The vertical displacement is 50 meters down. The acceleration is 9.81 meters per second squared down. And we're looking for delta t. So this is acceleration. So what kind of kinematic formulas for uniform accelerated motion can we use here to solve for t if we know delta sy and a? So we would immediately think about delta s equal to ut plus 1 over 2 at squared, right? And if we are looking at the vertical motion or vertical dimensions perspective, we would just transfer everything into the y-axis. So we have sy equal to uyt plus 1 over 2 ay and t squared. T is universal, right? So we will start by substituting numbers in. So we have 50 meters down, which is negative 50 meters, equal to, what is uy? What is the initial vertical velocity? And if we look back to this diagram, we will see that this baseball is fired horizontally, which means it doesn't even have a initial vertical velocity. So it's just 0. So this whole term right here would be cancelled. So this would be equal to 1/2 AYT squared. What is AY? AY is negative 9.81 meter per second squared times t squared. So after rearranging this thing here, we will get t equal to, after we calculate the thing, we will get a magnitude of approximately 10.194 second. And now we can use this value and substitute it back to this formula to help us to solve the question. So we will go back to horizontal dimensions perspective. So we can see that the horizontal displacement, which is the range, equal to delta t times the horizontal initial velocity, or because it's the constant, so it's just horizontal velocity, which is equal to 10.194 second times 12 meter per second, which will give us approximately 122.32 meter. And let's double check with a significant digit. So we have 2 sig digs. So we will say this will be 1.2 times 10 to the power of 2 meter. So this would be our final answer to this projectile motion. So key takeaway from this video. So when we're dealing with projectile motions and basically all types of projectile motions, first we need to make sure that we understand that on the vertical dimension, it is doing a free fall motion essentially. It is falling down with a constant acceleration, which is g. However, on the horizontal dimension, since there's no external forces, there's nothing acting upon the ball, so it will just travel with a constant, same initial horizontal velocity all the time. And this is under the condition that we're neglecting air resistance and any drags. And when we're dealing with actual problem solving, we should list our variables, define our directions, draw a simple diagram to help us visualize the situation, and start analyzing by maybe resolving the components if there's a need for that, and then look at a horizontal dimension and vertical dimension separately. And for each analysis on each dimension, think about what kind of things am I looking for, what formula can I use, what kinematic formulas can I use, and finally, the question is always asking for something, either in the vertical dimension or in the horizontal dimension. So we can always start by analyzing the other dimension, figure out something we need to solve for the other dimension. Thank you for watching, and I will cover the other 2 types of projectile motions in the subsequent videos. Please check them out. If you found this video helpful, please consider like and subscribe. See you next time.